So we're going to talk about Q, this reaction quotient, and we're going to have different types of problems, some where we're talking about gases and others where we're talking about solutions. So you can see two different kinds of Qs, one that depends on partial pressure of the gas and another that depends on concentration. So here is our equation again that we just saw. Delta G equals delta G naught plus RT, natural log of Q. And here we've expanded the term for Q. So P to the sub x is the partial pressure of a particular gas. And so in this equation, we have A plus B going to C plus D. The top of the line are the products. So we have the partial pressure of gas C, and this is over a reference partial pressure raised to the power C, the coefficient. And then also we have D, the partial pressure of gas D, over a reference raised to the small letter d. On the bottom of the terms for the reactants, partial pressure of gas A over a reference raised to the coefficient A, partial pressure of gas B over the reference raised to the to the coefficient B. Now what's great is that the partial pressure is 1 bar, and so that basically cancels out as far as we're concerned. And so the term for Q is much simplified. You won't see problems that have the reference in them. So you can just think about Q in terms of products over reactants. And you just have to remember that the coefficients in the reactions do matter. If you're talking about solutions, the only difference is that we'll be talking about molar. So we have 1 molar, so the reference term here also cancels out. When you see something in brackets, like C in brackets here, that's telling you it's a concentration term. So we have here Q is the concentration of C raised to its coefficient C, the concentration of D raised to its coefficient D over reactants, concentration of A to A, concentration of B raised to B. So the thing in X indicates it's a concentration term. So Q is just products over reactants, considering the stoichiometry of the particular reaction.